Conservation of aquatic life. Really happy to have you joining us today in the theatre and also online. My name is Kate LeSweff and I'm the manager of the Great Canadian Shoreline Cleanup. The Great Canadian Shoreline Cleanup is a joint conservation initiative of the Vancouver Aquarium and WWF, presented by Loblaw Companies Limited. We encourage Canadians from coast to coast to coordinate shoreline cleanups any time of the year, anywhere that land meets water. This could be anything from a lake, a beach, a stream, even urban drainage systems. Last year we had nearly 1,900 cleanups coordinated all across Canada, which resulted in about 140,000 kilograms of litter being picked up. The thing that we find year after year is that we find a lot of plastic items, from single-use plastics and other activities along our shores. Some of these things, sometimes they can be recycled, but today we're going to be hearing a little bit about another end-of-life solution for plastic by converting plastic into fuel. If you'd like to learn more about the Great Canadian Shoreline Cleanup, you can visit us at shorelinecleanup.ca. To hear a little bit more about this plastic to fuel conversion, I'm going to introduce Chloe Dubois, the president and co-founder of the Ocean Legacy Foundation. Thanks, Chloe.
Thanks, Kate, and thanks for everyone coming today to join us. We're here today to talk about oceanic plastic pollution, but also to talk about plastic to fuel conversion technologies in order to mitigate plastic pollution. So I invite you to come along with me now on a journey into understanding ocean legacy, into coming along to create a legacy which can support all present and future generations. In 2012, James Middleton and I co-founded the Ocean Legacy Foundation. Here, we have been developing exciting education, online mapping, expeditions, and using that in combination with plastic to fuel technology to transform our understanding of our plastic consumption and to mitigate plastic pollution. Our long-term vision is to help local and international communities develop these tools such as long-term education, plastic cleanups, plastic to fuel technologies, in combination with programs that support turning plastic pollution into a valuable economic incentive to clean it up. So I'm going to get started with what exactly we do. So the first thing we're going to start with today is online mapping. Our online mapping creates an international platform for anyone in the world to log on to our website and within seconds report a plastic pollution hotspot using GPS coordinates, stories, and pictures. This not only allows you to report these plastic pollution hotspots, but it connects the dots across worldwide, strengthening a resilient network of people who are concerned about ocean health. Not only can you post GPS coordinates, so actually this is what a plastic pollution hotspot looks like when you report it on our website. So you'll log on online, and then a little box will come up and you'll be able to put in GPS coordinates and actually go on to a global map. If you don't know the GPS coordinates, you'll be able to just click on the map where it is the plastic pollution you're finding in your community. So not only can you post these GPS coordinates, but you can enlist your ocean health organization, your project or initiative, and this allows us to create an illustrative database so that you can see local initiatives happening in your community. You can find allies, and this allows us to create a global capacity in focusing on collaboration instead of constantly recreating the wheel. So our expeditions. This is an exciting component of our programming. We support local and international expeditions, and we use the reported plastic pollution hotspots on our website to isolate these locations that we then bring people in to help clean up. When we do this, we engage local community members to help clean up the plastic pollution. We then use our education and programming and then look at the possibility of developing plastic to fuel technologies with that community. So this is what a typical cleanup looks like for us on the BC coast. So you'll see here we get a lot of styrofoam, really big items here, lots of rope. And this is actually on Brooks Peninsula, which is on the northwest coast of Vancouver Island. This is from one of our cleanups that happened in February. So off of a 2-kilometer shoreline, we collected over 70 cubic yards of material. And just to give you an understanding, that boat you see here, that's a 25-foot boat. So it gives you some perspective just how concentrated these areas are. And the BC coasts are no different from coasts around the world, experiencing similar concentrations of plastic. So how do we do this exactly? Right now, we're working with a small fleet of vessels off the northwest coast of British Columbia. And we're looking to increase our capacity by investing, escape? There we go. We're looking to increase our capacity by investing in a larger vessel. So this vessel we've been looking at on the left here is called the Pacific Reefer, and it would allow us to pack over 70,000 pounds of plastic at any given time. This vessel has a hydraulic moving crane on the back and would allow us to pick plastics up out of the water as we ferry them across from the shoreline. This would allow us to carry a crew of about 12 people around with us and would give us accessibility to concentration spots around the world. We're also looking at other alternative options, as the vessel on the left is going to be a converted fishing packer. The vessel on the right here, we've been looking at costing a solar diesel electric boat in order to reduce our carbon footprint. However, this is still under development. So our education really excites me, and it focuses on transforming what we consider garbage into what could be an incredible, valuable urban resource. We are creating a community guidebook right now which focuses on recycling basics in combination with using plastic to fuel technology. And we also focus on how we can reduce our plastic consumption and how we can create our first pilot program with economic incentive and value to all resin code plastics. This has never really been done before. So I want to go into what exactly is an urban resource. Well, at Ocean Legacy, we believe an urban resource is really anything that you've used and you're about to throw away in the garbage and forget about. We can take your broken lawn chairs that you can no longer use, your old plastic keyboards, flower pots, even some of your clothing, and we can upcycle that into a fuel. Other items that we use every day, such as straws, plastic utensils, the tops on your disposable coffee cups, which is a huge one, disposable plates, I mean, the list goes on. So how exactly do we do this? So we're investing right now. We're investing right now in Blessed plastic to fuel technologies. We've chosen Blessed Incorporated because it has been recognized by the United Nations Environmental Program. It is incredibly efficient and best in its class. We can convert approximately 1 kilogram of plastic materials into about 1 liter of fuel, which requires 1 kilowatt per hour of power. And the exciting part, it gets better. We're actually looking at creating a 1-ton mobile unit that would service the smaller coastal communities around British Columbia. We're doing this, sorry? We're going to save questions till the end, yeah. So we're doing this because this is the most cost-effective way for a lot of these smaller, more remote communities that can't afford a plastic-to-fuel machine of their own. And a lot of these smaller communities don't have sustainable waste management options in place. So a lot of this material, even in our own country and province, are getting burned and buried or sent to the landfill. So this is a front view of what the mobile unit will look like. Inside, we have built a conveyor belt, which leads to a plastic chipper, a plastic washer, and then it is combined with plastic-to-fuel technology. It will be built in a 40-foot shipping container and will have the ability to travel via boat or road. This has never been done, to my knowledge, in Canada before. So it's really leading edge stuff in regards to sustainable waste management and how we can be upcycling all of these disposable items that so many of us use every day. This is a side view, the two bottom pictures here, and then the top view of the mobile unit at the top there. So why plastic to fuel? Plastic to fuel offers us an incredible solution to disposing plastic marine debris because as much as the debris we collect is incredibly bulky and it's degraded and dirty. This creates a challenge to using conventional recycling systems. So we're able to put this marine debris, once it's been chipped and cleaned, right into the processor, which eliminates it going to the landfill. And believe it or not, most beach cleanup organizations, I mean, it's great that they're doing that effort and getting it out of the natural environment, but then it just goes back into another environment. Most often, it gets put back into the landfill. In the fall of 2014, we did an expedition down to Mexico, and this was the exact story we found down there. We took 12 local villagers out from the village of Ilapa, and we started our search for plastic pollution hotspots. Sure enough, we found one the same day, and we cleaned it up. But all that material we spent so much energy collecting just went back into the landfill because no recyclers would actually take it. So if we were able to take this 1-ton mobile unit, or even our demo unit and showcase this technology to communities around the world, we would be able to educate and show people that there are alternative sustainable waste management solutions, and they're readily available right now. By combining plastic to fuel technology with our education and programs, which allow people to return all plastics for an economic value, we are creating a world-leading approach that could help diminish poverty and eliminate plastic pollution worldwide. So we're starting locally in British Columbia, and we're starting with a few legislative initiatives. We're asking local coastal communities and their municipalities to support creating a green credit. This green credit would be awarded to organizations who defer each cubic yard of audited plastic materials from the landfill. Currently, much of the material we collect is very bulky and it doesn't weigh a lot. So putting it into the landfill takes up valuable landfill space, and it doesn't create a positive economic return for the landfill. By creating this green credit, we will be encouraging organizations to divert their materials from the landfill. Looking this up by then asking those same municipalities to ban all plastics from the landfill. This has never been done before. And so far, we've received incredible support, and we've been re-invited back to keep presenting and working with the Coastal Community Alliance to create this reality. This would be assured on applications to convert all plastic materials using alternative technologies, such as blessed plastic to fuel conversion. Plastics make up approximately 30% of our landfill space. By creating bans on all plastics entering into the landfill, we would not only be reclaiming an incredibly valuable urban resource, but we would be able to process these items sustainably. This would extend the shelf life of our landfills, while British Columbia communities have the time to develop new policies and strategies to support a zero waste mandate. So this is a graph just showing you, based on a 30% reduction, we're able to get about 10 to 15 years extra out of our landfills. And this is important because many communities don't want to see another landfill in their backyard. There's an incredible push right now to explore alternative options, which is encouraging because plastic to fuel technology offers those solutions. By creating legislation that supports a mandate of zero waste, in combination with practical technologies, community programming that creates economic incentives to collect all plastic materials, and then combining that with our online map and accessible systems which connects a global community, we believe is a world-leading approach in stopping plastic pollution before it even reaches the ocean. We would be creating stronger localized economies for impoverished people everywhere. And we believe this would create an inspired, connected, and resilient global movement to rise to face the great challenges of our lifetime. Thank you. So I'm just going to introduce Jason Tanay, and he is the founder and representative of Resynergi. And Resynergi is the sister company of Blessed Incorporated Technologies, and he's flown a very long way to be with us today. So please give it up for Jason.
Thank you. Give me a second here to switch presentations. Let's see here. So again, I'm Jason Tanay, and I am the founder of Resynergi, and we're a small company. We're actually based in Washington State, and also we have an office in California. Excuse me. Is that better? Okay. All right. Okay. So Resynergi is a partner with this company that's out of Japan called Blessed Company. And Blessed started about 13 years ago and around the premises of converting plastic to oil. Not just fuel, but to oil, so some of those oils can be chemically recycled back into plastics or other materials. And what we do as a partner with them is we develop, we promote, and we build these scalable plastic to oil systems, and the goal will be to build them actually here in the Northwest region, probably within the year. So the systems, having been around for quite a while, have gotten quite a bit of attention, including the attention of the United Nations, as you'll see here. The technology has been endorsed very early on. Rather than being a technology that went into developed countries, it actually finding its way into undeveloped countries, because while we have well-organized landfills, a lot of developed countries do not. And a lot of waste, even in places where plastic waste normally wouldn't be generated, was getting piled up from nonprofit organizations engaging in those locations. So the design of these systems is quite unique, and it's won some awards. It's very cost to operate. The systems scale very nicely. They start small and they grow larger. And what you're seeing here in front of us is just a demo unit that we use for education. Universities will use them for experimentation. We have about 180 systems around the world in about 30 different countries. So we're the most deployed technology like this, and we're unique in the fact that we don't go to build large plants. Others that are in this space are really building manufacturing plants. This is a decentralized technology that can get close into sources. We have operations running in Africa, Asia, Europe, India, Japan, here in North America, and some in the South Pacific and in the Caribbean and Latin America. And our customer base is really diverse. We have governments using the systems. We have nonprofits. We have commercial. We have, obviously, I mentioned education and research organizations, and even military looking at the applications because they have a fair amount of plastic waste. Over the right side, you see some of our customers, and they, again, range exactly as I was saying, from commercial entities to nonprofits and private entities. So what I wanted to share a little bit about is some plastic facts and why plastic is such the issue that we see today. So A lot of these are based around U.S. information because I'm from that area, so I apologize. I realize we're here in Canada, but it's very much a mirror of what goes on in Canada. And it's quite shocking because the U.S. is a fairly substantial population. But basically, in 2012, only 9% of our entire waste stream was being recycled. And and that waste stream was 32 million tons just coming from the municipal solid waste, mostly consumer plastics. A lot of industrial waste wasn't even included in that number. So if we were to take that and convert it back into oil, it's roughly about 30 billion liters of oil, or about 35 billion Canadian dollars in value. So it's quite a substantial amount of material. Right now in the U.S., the annual cost for hauling that waste, just the vehicles moving back and forth to landfill, is around $2 billion. So it's a significant cost from an operation standpoint and significant from amount of CO2 and other emissions that come from moving plastic around that's just ending up in landfill. So in our landfills right now, we have about 2 trillion tons of material. So it is just an amazing number. And yesterday someone said, can you count to 2 trillion? And I said, it would take me an awful long time. And I'd rather not try that. So it is just really a shocking amount. And it's hard to fathom that that much is sitting there. So of that 9% of materials that in 2012 were being recycled, 6% of those were going off to China. And the reason is U.S. had basically tons of imports coming in from China, as a number of other countries had, and empty containers going back. So containers were cheap. A lot of states, particularly on the West Coast, like California, tend to have limitations on how much material can go in the landfill. So they would send it back to China under the auspices of being recycled, but that wasn't always happening. There was a large amount accumulating in China. Some ends up being incinerated, some ends up going into coal plants. A lot just is just piling up. And as a result, in 2013, the Chinese put up a barrier known as the Green Wall. And basically what this was is they shut down 30 or 40 of their major importers of plastic. So they still import some materials that they actually are recycling, but they have just had a glut of materials, and it's not something that they can manage. So other problems that are kind of contributing to the situation and the lack of a recycling side is that basically oil prices have fallen, and recycling plastic is not really economically viable for a lot of materials that are in the stream, because it's cheaper just to produce new ones than to haul these into a facility and process them. So over the next 20 years, we do expect oil demand to grow. It's an inevitable fact. We have hydrocarbons linked to our economies, and it's going to be consumed. So we do know that using this type of technology, we can actually produce fuel at a much lower impact to the environment, carbon release, than taking new oil out of the ground or using other related methods for obtaining other hydrocarbons. So there's a lot of effects from employing these type of technologies. What is the problem with plastic? The problem with plastic is it's an inevitable part of our lives now. It's very useful. It's used in everything from medical devices to the chairs that you're sitting on right now. And so that has created a huge industry. In the U.S., it's the third largest industry, and it accounts for about $400 billion in revenue annually. So that is not going to go away. And what has happened, because it's such a large industry, is the complexity of those polymers has gotten really advanced over years. So recycling and downcycling even gets more complex, because you've got a standard set of codes that we see on plastics, and then there's the final group, which is number 7, which can be anything. It can be plastics that are hydrocarbon-based mixed with plant oils. It can be a number of things. And so those complexities also make the recycling picture a real difficult thing. So some of these pictures that are showing up here, some are from Asia. For examples, like over to the left side, you'll see boat. I believe that's out of Indonesia. Over the right side, you're seeing a boy standing in, I think, Manila Harbor in Philippines, taking plastic. In the center is obviously a fairly shocking picture. That's a bird, I think, from the Midway Islands that is, in its stomach, has a variety of different plastic items, including a cigarette lighter, which is a little hard to see in the presentation here. So, because the plastics don't easily decompose, they are now a significant source of pollution in the world. They're in the oceans. They're toxic when they're burned. And they've entered our food chain. So we're ingesting these when we ingest seafoods and other things. And it has an impact on humans directly. It lowers birth rates, things like that. This picture is taken from, I will give credit, is from the Wall Street Journal earlier this year, and it shows the distribution of plastics that are getting into the ocean and estimates on it. And there's some irony in here because a lot of the developed countries, as I mentioned, the U.S., Canada, we were all shipping our materials to China. And while a lot of material is getting in the ocean from China, you know, a lot of that blame, I believe personally, lies on the developed countries where we're sending the materials over there. Because if we can't handle our materials, why should we think that other countries should be capable? So, and much of what we see in many of the Southeast Asian regions are similar kind of things, where you had countries that traditionally didn't have a lot of plastics early on in their societies, and then they come in, and then the way they are disposed, for example, a child might have had a rice ball that was wrapped initially in a banana leaf or a tea leaf, that gets discarded by a roadside, and it biodegraded. Now if you discard a plastic wrapper from some food, it doesn't happen that way. And it's easy to get into rivers and rivers to oceans and so forth. And that's happening in most of the developing world. A little bit about what we are proposing as a solution here. So plastic to oil facilities, according to the American Chemistry Council last year, did a study, and they found that in the U.S. alone, that the economics of this could support 600 facilities. And those facilities would be processing anywhere from 20 to 100 tons of material a day. And that would create about $9 billion in annual economic output, up to 40,000 jobs. So this is something that is economically viable to do and can be done from our perspective in an environmentally sound way. And our approach to this is to try and do systems that can start very small and scale up. So a customer does not have to have 60 tons of material or 40 tons of material. They can have a very small amount of material, and it is modular, so it can expand and you can pay as you grow. The system is all electrically based, and therefore we're able to employ new technologies in a very efficient way, and we take about a kilowatt of power to create a liter of oil from a kilogram of material. So we're efficient. We try to convert that and maximize the amount of oil that we get off, and other things that come off are a residue and some carbon dioxide and water, but that's it, and we control those things very carefully. Our technologies are all designed to be very simple. Rather than being like a manufacturing facility, they're all touchscreen based. They're designed to be something that can be learned by most anyone in a few days. 2 minutes? Okay. So with regards to that, I will skip forward a little bit, but the technology works in the following ways. It's called pyrolysis. Pyrolysis is basically heat decomposition of a material without the presence of oxygen. And how we do that is, in the first stage, we have granulated materials that are fed into our system. The materials begin to melt. They are decomposed further as they are liquefied, and then they are gasified. They go through a condenser, and then they're either broken down into fuels or into an oil that can be chemically recycled back into materials. The only things that come off in terms of emissions are mostly water and a small amount of CO2. In the process, we create some benign carbon, and that's usually less than 1%. In terms of the carbon footprint, we are a very small amount. Our machine, when we process a kilogram of carbon, it's compared to incinerating it, we make between 100 and 200 grams, whereas if you incinerate, you end up with about 3 kilograms. In terms of our solutions, you can see here we are proposing both fixed facilities and land-based facilities. Looking at the case of cleaning up the oceans, the challenge is probably it's more difficult to remove materials out of the ocean, but there are a couple of thoughts on how to do that and whether or not it's a sound practice, but both processing from onboard ships and also processing on land but collecting at sea. And this is just a look at a few of our systems. You'll see the small desktop system, the smallest of our commercial systems here, and some of our larger systems as they go up by tonnage, 1, 2 ton, 4 ton, and so on. And I will skip through this with this evolution of our system, but these are just a few pictures. This is a facility called Tokunoshima. It's a small island down by Okinawa, and they basically are a municipal waste facility. They incinerate their waste. They've pulled their garbage out, and they are converting, they pull the plastic out, and they're converting it into oil, as you can see here. And what they're doing is they get a lot of rain because they're in a tropical region, and instead of expending extra calories and more emissions on incinerating the rest of their waste stream, they're taking this oil and they're running boiler systems to take the oil off, as well as they're making some fuel for vehicles. And it's all solar powered. And I will skip through this one pretty quickly, but this is a chicken processing plant that basically converts waste streams into heating for the facilities. Thank you.
So we have time for 1 or 2 questions. If anyone in the audience here has a question for either Jason or for Chloe, if you just want to raise your hand. Yeah, go ahead. So just so that we get that question, the question was about banning plastics and the kinds of plastics that we might be interested in getting rid of.
So we're proposing on banning all plastics from the landfill. Yeah. Jason didn't get to speak about it, but he's developing systems right now. Future models will be able to process all resin codes 1 through 7. At the moment, we can process 1, 2, 4, 5, and 6, with the exception of number 3, which is PVC, and number 7, which Jason explained is a mixed material. Yeah.
Are there any other questions? Yeah, go ahead. So the question is, how will banning plastic from the landfill work? So maybe Chloe can talk to that.
So we're still developing that strategy, and it will look different for each municipality. Right now, we've done a presentation for the CVRD of Courtney Comox and for the mayor of Courtney Comox, and he's incredibly interested in developing this. And these systems, they'll look different for everyone. Basically, the landfill just won't take any plastic materials, and they'll be diverted off to the side. And this is the most short-term, this is something that can be done right away and is the most cost-effective in creating another diversion system. So that's essentially how it's gonna work.
So maybe I can make a comment. So not all materials should be converted into oil. And we're not saying that, or with other technologies converted into energy. Some materials are justifiably recycled, and they are economically justified. So, for example, PET, the PET bottles, Coke, water bottles, those can definitely be downcycled, and they are being now recycled back 100% by a few organizations into new water bottles. So there is a good economics model that works for that. So some materials that she is talking about being diverted from landfill have strong economics behind them. So it's not all about converting everything into oil.
And, oh, sorry. Just in my presentation, I also said that these materials will be banned with the assured application with the uses of alternative technologies. So this doesn't necessarily mean plastic to fuel, but we're banning these materials so that they don't end up being burned or buried in our landfills, which is unsustainably long-term. Yeah.
So would it be like at the landfill they would sort of, because what if plastic comes in the like big black plastic bags and you can't tell that they are in there, so then would the landfill sort it?
Okay, so we've got some questions here about how this might work. I think we're running out of time though, so perhaps if you want to come down and talk with Ocean Legacy and with Blessed afterwards, and you're welcome to do that. But I think we're going to wrap it up here. So I wanted to thank you very much for joining us here at the Vancouver Aquarium and also through our online channels. And if you'd like to learn more about the Great Canadian Shoreline Cleanup, we'd love you to visit us at shorelinecleanup.ca and join the more than 50,000 people all across Canada who register for our cleanups every year. I'd also like to bring to your attention another public program we're hosting here at the Vancouver Aquarium in collaboration with the Georgia Strait Alliance on Monday, 8th of June. It would be about celebrating the Salish Sea from 6 p.m. Thank you very much for joining us and have a great day.